Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. And today we're going to be talking about three-dimensional figures. It's several pages of notes, but it's mostly just facts and maybe an example. Somehow all of the creatures that live in my house are completely losing their mind. So if you hear a crazy cat or maybe a barking dog, don't think anything about it. Everything is perfectly, completely normal. First, we're going to look at the cube. The cube is like a dice, like a six-sided dice. All the sides of the cube are squares. Every face is a square. So we can know some stuff about the cube by using some formulas that we're going to talk about. First, S stands for side in these formulas. So here, where we've got an S, 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 those are all sides. Since every face of the cube is a square, all the sides are the same length. These animals are completely insane. V is the volume of this cube. That's equal to S cubed, or side times side times side, or length times width times height. Doesn't matter. All the sides are the same length, so it's just S to the third power. I'm going to erase that because it looks a little bit like a 5. Can't have anybody having confusion. There we go. SA, surface area. So V is volume. SA is surface area. And that is 6 times S squared. So let's think about why that's the way it is. The area of a square is length times width. So that's S times S, or S squared. There are 6 sides to a cube, so we need the surface area to be multiplied by 6, to 1 for each face of the cube. So that, hence, we have S squared for our surface area. Let's look at some facts here. Is it a polyhedron? Yes. Why is that? Because a polyhedra is a solid with all flat surfaces that enclose a single region of space. So the cube that we have here, all of these sides are enclosed. There's no openings, so yes, it's a polyhedra. What's an example of a base, you say? Well, these are squares, so we'll use this parallelogram quadrilateral symbol. And one base is the top of the cube, B, F, G, C. Another one, just for fun, we could use the bottom. A, D, H, E is another base. Faces. So the bases are the top and the bottom. Faces are along the outside of the cube. So let's look at what some of those are. We'll have 4. We'll have B, A, C, D is the front face, and C, D, G, H on the right, F, G, E, H in the back, and B, F, A, E, or E, A, so sorry, on the left. Those are the 4 faces that go around the outside. Edges. The edges are pretty much the lines along the outside. So let's go through these. We'll have line segment BF, segment FG, segment CG, segment CB, and lots more. We don't need to list them all. The edges are the lines that go around the cube. Segment BA is another one that just goes in another direction. Any of the lines around the outside of the cube are the edges. Lastly, vertices, those are all the corners of the cube. So A, B, C, D, oh, that's an F, D, E, F, G, and H are all vertices. A little example, if S equals 4, find the volume and surface area. So we have S equals 4. The volume, we said, is S cubed. So the volume is 4 cubed. That's 4 times 4 times 4. That's 64. And it's going to be in our units cubed. Also, if S is 4, we want to know the surface area. That was 6 times S squared. So that means it's 6 times 4 squared. Well, 4 squared is 16. So that's 6 times 16, which is 96. And that's in units squared. So that's a cube in a nutshell. Moving on, rectangular prism. Looks a lot like a cube, and you're right. The only difference is the sides are not always squares. They're more generally a rectangle. Let's see if I can get this to work. There we go. All right, so formulas that we need to know. L is the length. I can hear your shock that L might be the length. W, you probably can guess, is width. H is height. These matter because it's a rectangle, not a square. The volume is length times width times height. Surface area, 2 length width. That covers, in this case, the bottom and the top. We're assuming, and rightfully so, that those are the same rectangle. And then to that, we'll add 2 width times height. And that will give us the right and left end. And then we'll do plus 2 length times height. And that will give us the front and the back face. So is this a polyhedra? Yes, it is. It's an enclosed space. So it's definitely a polyhedron. Bases are the bottoms and tops. So we'll just list one example this time, since we remember this from before. Base is A, E, H, D. The other one is, oh, that's a triangle. Holy moly. Other one is B, F, G, C. Faces, we've got 4 of these. So B, C, D, A. That should be a square there, a rectangle. And C, G, H, D. And F, G, H, E. And B, F, E, A are our 4 faces. Edges, we know what these are. These are the lines that are connected by points all around our prism. So for instance, we could say BF or AE or segment CD. Any lines around the prism will work. Vertices are the letters that make up our prism, yeah. So A, B, C, D, E, F, G, and H. Now, a little short example. If L equals 2, W is 3, and H equals 4. Find the volume and surface area. Well, the volume we said is length times width times height. So the volume is 2 times 3 times 4. Well, that is 6 times 4. That's 24 units cubed. The surface area, we said, equals 2 length W plus 2 width height plus 2 length height. So that's 2 times 2 times 3 plus 2 times 3 times 4 plus 2 times 2 times 4. Let's figure all this out. 2 times 2 is 4 times 3 is 12 plus 24 plus 16. That means the surface area is 52 units squared. So we've covered a cube and a rectangular prism. Now we have a square pyramid. Square pyramids have a square at the bottom and triangles that are on all 4 sides that meet in the center. Some formulas we need to know. S, again, in this case, is side. H, you could have guessed, is height. I want you to note here about height. Height is the distance from the bottom of the pyramid to the very tippy-toppy. L, again, is length. I make my L's a cursive L so we don't confuse them with the number 1. V, volume, is 1/3 the base times the height. You might recognize this from like a triangle is 1/2 the base times the height. I need to define this as well. B is the area of the base. So we can also write the volume as 1/3 S squared times height, because the volume or the area of our base is side times side, which is S squared. Surface area is going to be 1/2. We're going to say P is the perimeter of the base. So 1/2 P times length plus B, area of the base. Is this baby a polyhedron? Yes, it is. Fully enclosed, cannot be penetrated. Bases, only one base in this case, and that's the square on the very bottom, which is JKLM in this case. Faces are going to be the 4 triangles around the sides of the pyramid. So triangle JNK, triangle KNL, triangle MNL, and triangle JNM are all of the faces. Edges are any of the lines that go around the pyramid at all. So segment JK, segment NK, segment LM, any of those are edges. Vertices in this particular case are going to be J, K, L, M, and N. Let's find some things out about this trusty pyramid that we've got. S is 6, H is 4, and L is 5. We want to find the volume and the surface area. Cats. We said above the volume is 1/3 the area of the base times the height. Well, that is 1/3. The area of the base is S times S, which is 36, and the height is 4. So this will be 1/3 of 36 is 12, and 12 times 4 is 48. And volume is always in units cubed. Surface area, we also said, is going to be 1/2 the perimeter of the base times the length plus the area of the base. So 1/2, the perimeter of the base is 4s. So 4s is 24. The length is 5 as L, plus the area of the base is s times s. That's 36. So the surface area, half of 24 is 12. 12 times 5 is 60 plus 36. And 60 plus 36 is 96 units squared. Really, all of these figures are just putting together the things that you already know about how to find information out about figures that you've been learning for years. We're just putting it all together. A right cone, you can see here, has a circle at the bottom and a triangle, a cone that comes off of that. It's a right cone because the angle made between the vertex of the cone and the base of the circle is a right angle, is 90 degrees. R we have here is radius. You might have guessed that because we're dealing with a circle in this case. H, as usual, is height. L, not surprisingly, is length. Or actually, I don't want length because it's not going to make any sense in this particular case. It is slant height, which you can see is the length from the base of the circle, the base of the cone, to the tippy top. V is the volume. That's 1/3 pi r squared h. So a lot like a triangle and a circle put together. Lastly, surface area is pi RL plus pi r squared. Is it a polyhedron? No, it is not. Polyhedrons have to have all straight edges. So this is a no because it has curves. The base is circle B. We haven't talked about how to label circles yet, but it's the circle with a dot in the center, and the point at the center is the label. So that's circle B that is our base. Faces, there are no faces because the sides are curved. So we can't have any faces if it's not really a polyhedron. Edges, not any straight lines. So there are no edges. And strangely enough, there's only one vertex, and that is A. That's at the top of the cone. If R equals 3, H equals 4, L equals 5, find the volume and surface area. The volume we said above is 1/3 pi r squared h. So that's 1/3 times pi times 3 squared times 4. So that is 1/3 pi times 9 times 4. Well, that's 36 divided by 3 is 12. So our volume is 12 pi units cubed. You can just leave pi in this case. We might ask you to do something different on the homework, like make it a decimal point. The surface area is pi RL plus pi r squared. So that's pi, and then not r like I just wrote, pi times 3 times 5 plus pi times 3 squared. So we've got 15 pi plus 9 pi. So our surface area is 24 pi in units squared. We've got one more. This is a lot, I know. I'm throwing it all at you at once. But it's mostly just facts that I want you to write down. Right cylinder, circle on top, circle on the bottom. It's right angle where the body of the cylinder connects to the a circle at each end. That makes a right angle. Formulas we need to know. R, again, is radius. H is height. V, the volume, is pi r squared h. And the surface area is 2 pi RH plus 2 pi r squared. Is this a polyhedron? No, because of the curves it has everywhere. Bases, we have 2. One circle on the top, one on the bottom. So circle M and circle N are our 2 bases. Faces, we have none because there are no flat sides. Everything is all curvy. Edges, none. Everything's curvy. Vertices, this one is different. There are none. So if R equals 3, H equals 5, find the volume and surface area. Volume V, we said above, is pi r squared h. It's an awful pi. So our volume is pi times 3 squared times 5. So that is 45 pi in units cubed. Surface area, we said above, is 2 pi RH plus 2 pi r squared. That means it's 2 pi times 3 times 5 plus 2 pi times 3 squared. So the surface area is 30 pi plus 18 pi or 48 pi. Oh, and it's in units squared. Last but not least is the sphere, which we know about. R, again, stands for radius. The equation for volume in this case, maybe if I can get everything to cooperate, is 4/3 pi r cubed. And then the equation for surface area is 4 pi r squared. Is this a polyhedron? Absolutely not. Everything is a curve. Bases, none. Faces, none. Edges, no such thing. Vertices, none. Let's get these last equations all done and out of the way. If R equals 4, find the volume and the surface area. The volume, we said, is 4/3 pi r cubed. That means it's 4/3 pi times 4 cubed. That's 4/3 pi times 64. So our volume is 256/3 times pi in units cubed. Surface area is 4 pi r squared. So the surface area is 4 pi times 4 squared. So that's going to be 64 pi in units squared. I know this is really long, and I'm so sorry about it. We need all this info. You're going to be able to use this on your quizzes. I hope it all makes sense, and I hope to see you soon.